Today, we're going to completely demystify the everyday magic of your smartphone and follow the literal journey of your voice. I mean, you probably make calls every single day, right? You press a name on a glass screen, hold the phone up, and just wait for that familiar voice on the other end. But have you ever stopped to really think about the physical, structural, and digital gymnastics required to make that happen? Well, today, we're going to break down the invisible, high-speed sprint your voice takes across the globe. Okay, here's our roadmap for the journey. First, the illusion of instant magic. Second, digitizing your analog voice. Third, the underground network routing. And finally, rebuilding the sound. Let's dive in. We take it entirely for granted, but I want you to really picture what physically occurs the exact moment that greeting leaves your lips to reach someone thousands of miles away. It's so incredibly easy to just treat our phones like magic boxes that teleport our voices. Actually, teleportation would probably be simpler, but there's no teleportation here. There is only physics, data, and an incredibly complex global infrastructure working in absolutely perfect harmony.
It feels like an instant, effortless connection, doesn't it? But the reality is a massive, high-speed data transformation. We press a button and the connection seems immediate. Beneath that super user-friendly surface, though, your voice is literally being dismantled, hurled across the planet, and reassembled, all before the person on the other end even realizes you've spoken.
Section 1. The illusion of instant magic. Confronting the assumption of a phone call. To quote our source material directly here, your voice undergoes a massive transformation, traveling through a complex network of antennas, fiber-optic cables, and massive routing centers in fractions of a second. That perfectly captures the sheer scale of the journey. Your voice doesn't just beam straight from your phone to your friend's phone. It goes on this perilous, high-speed sprint, navigating an absolute labyrinth of antennas, deep-sea cables, and routing centers. And the most mind-blowing part? It manages to do the whole shebang in mere fractions of a second.
Section 2. Digitizing your analog voice, preparing for the physical journey. So it all starts in the physical world with you. Your voice acts as an analog sound wave. When you speak, you are literally pushing and vibrating the air right in front of your phone. Your voice isn't data yet. It's just raw, physical energy moving through the atmosphere. But a mobile network can't really do anything with just vibrating air. It needs to translate that energy first.
Here's how that happens. First, a tiny membrane inside your phone's microphone feels those physical vibrations and turns them into a fluctuating electrical current. Next, an analog-to-digital conversion chip, or ADC for short, steps in. Since your phone can't transmit raw sound waves over the air, this little microchip digitizes that electrical current into ones and zeros. Finally, your phone's antenna takes that digital data, embeds it onto a high-frequency radio wave, and fires it right out into the environment as an electromagnetic wave. Now, what is truly crazy here is the sheer speed of that conversion. That internal microchip samples your continuous analog voice wave thousands of times every single second just to generate that binary code. It's basically taking thousands of microscopic snapshots of your voice every second to ensure that the digital version sounds exactly like the real you and not like some clunky robotic approximation. Section 3. The underground network routing, the Great Transit. At this point, your phone is essentially operating like a fancy two-way radio looking for a base station. The map of your city is divided into geographic areas called cells, and each cell has its own tower. That tower catches your radio wave in mere milliseconds. It acts as the absolute crucial bridge between the wireless sky and the wired earth. The journey rapidly accelerates as your digitized voice smashes into the nearest cell tower's antennas. And here's a fun fact. This is actually the only part of the journey that happens through the air. The moment the tower catches those radio waves, the wireless portion of your wireless call is completely over. Because boom, in a fraction of a second, the tower converts those wireless signals back into digital electrical data. And that data plunges deep underground. It enters the backbone transit, high-speed fiber-optic cables, sometimes even running completely across the bottom of the ocean, that connect back to the core network of your mobile carrier. It's kind of fascinating to realize that our supposedly wireless calls actually spend the vast majority of their time buried beneath the dirt. And from down there, it hurtles at the speed of light toward a massive computerized data center to find its final destination. Your data is moving incredibly fast, but, well, it needs directions. It needs to know exactly where the person you're trying to reach is currently located. So, enter the Mobile Switching Center, or MSC. Think of this as the ultimate digital traffic cop.
It checks the specific number you dialed and instantly queries a global database. Within milliseconds, the MSC figures out exactly where the recipient's phone is located anywhere in the world, and it routes your call data toward their nearest cell tower. It is a wildly fast, automated switchboard. But what happens if you're on the move? Say you're cruising down the highway while talking. Well, your phone continuously measures the signal strength of nearby towers. As you drive away from your current tower, the signal weakens. But before it drops entirely, the network automatically performs a completely seamless handover to the next closest tower. It just passes the baton without dropping a single piece of your digitized voice, ensuring the data stream remains totally uninterrupted. Section 4. Rebuilding the sound, the resurrection at the receiver. Now, everything we just discussed, it basically runs entirely in reverse. The target cell tower beams radio waves down to the recipient's phone. Their phone picks up the signal, strips away the high-frequency carrier wave, and extracts your digital stream of ones and zeros. Then, a digital-to-analog converter, a DAC chip, translates those binary numbers back into a continuous electrical current. Finally, that current fires a tiny electromagnet located right behind their phone speaker. And here is the grand finale. That electromagnet causes the speaker cone to physically vibrate. Those precise vibrations literally push the air into the recipient's ear, recreating your exact voice. And keep in mind, you aren't just sending a one-way voice memo here. You're having a natural, real-time conversation, which means this entire invisible journey is happening back and forth simultaneously, hundreds of times every single second. So it leaves us with this final thought to ponder. The next time you effortlessly say hello into your phone and hear a response from a friend across the globe, will you simply accept the illusion of instant magic? Or will you take a second to marvel at the invisible, high-speed journey of antennas, microchips, and underground cables making it all possible? Understanding the physical structure behind the tools we use every single day makes the world just a little bit more fascinating, doesn't it? Thanks for joining me on this explainer, and keep staying curious.